factoring quadratics by grouping. So what we're going to do in this presentation is we're going to take a look at a standard form quadratic and be able to factor it by grouping. But again, before we go there, let's kind of just revisit what the grouping concept actually is. And when we group, it basically means that we're going to go ahead and take the first two and the last two terms and kind of group them together. And from there, we pull out a GCF, in this case 2x. In the other case, there is no GCF, so it's just going to remain x plus 2. On this step, remember, when we're factoring by grouping, it's important that we realize that these need to be the exact same expression. Since they are the exact same expression, we can then factor the x plus 2. And then our other set of parentheses is going to be what the coefficients or the numbers in front of there would have been, which would have been 2x, and in this case, plus 1. That's just a brief review on how to factor by grouping. But now what's going to happen is we need to get to this step. All right, how do we get our quadratic to get two middle x terms? And I'm going to demonstrate that here in 3 examples. And when I'm going through these 3 examples, you're going to see that I'm basically working through this little 4-step procedure down here. All right, step number 1, I'm going to actually multiply a times c together. A is 4, c is 3, that gives me 12. Check that off, I multiplied a times c. Now, what factors of 12 equal b? All right, so what factors of 12 result in 13? Well, that's going to be 1 and 12. Check that off the list. That's what I'm going to split b into. This is the critical step. I'm going to take this 13x and I'm going to make that an x and a 12x. Everything else stays the same. And I haven't changed the actual expression at all. I just split the 13x into x and 12x. Now I can actually factor by grouping. I'm going to go ahead and put parentheses around the first 2 and the last 2 terms. Pull out my GCF of x. In this case, my GCF is 3. And this is my moneymaker step. I always have to make sure these are exactly the same. They are, so we're going to go ahead and factor out that 4x plus 1. I'm left with an x plus 3. There's our factored form. Now that you've seen a model, you can actually pause and make a prediction on the next 2, but I'm going to go ahead and continue working through these so that we have a couple more examples to go ahead and reference. I'm just going to slide this guy over a little bit, give me a little more room. All right, step number 1, AC. AC in this case ends up giving me a negative 24. That's important in this case because remember the sign's going to be important. 4 negative 6 give me negative 24. So then factors that equal 5. Well, that's going to be unique because remember this is going to be 8 and negative 3. 8 times negative 3 is negative 24. 8 combined with negative 3 gives me a positive 5x. So the sign's very important in this case. I'm a little tight here, but I can see I can separate this. Whenever I have a positive and a negative, I like the first number to be negative. And I'll kind of show you why here in a second. And this is going to be a plus 8x minus 6, and my 4x squared stays right there. Now, I like this being the minus because now whenever I do my parentheses, I don't have to worry about having a distribution issue with a negative there. We'll discuss that in a little bit more depth later on. But here I'm in my comfort zone. My GCF is x, which is 4x minus 3. GCF here is 2. Again, resulting in 4x minus 3. Those are the same. That's my look for. That's a good step right there. 4x minus 3 gets factored out. I'm left with x plus 2. There we go. If we do one more example here, I'm going to just try to, can I move that stuff over? Well, let's actually do this. Let's move this on over to get here our last example. And again, we're just going through the same process, but this has a nice little twist at the end. So again, maybe if you pause and try this one on your own, you can see if you can anticipate the twist. But here we go. AC 36. All right, 9 times 4 gives me 36. Factors of 36 that equal 12. Factors of 36 that equal 12. Well, 1, 36, 2, 18. I have 3, 12, 4, 9. Oh, there it is, 6, 6. All right, so in this case, we're going to split this into 6x plus 6x. Still got that 4, still have that 9. We group them. GCF in this case is going to be a 3x, which leaves me a 3x plus 2. This is going to be a GCF of 2, 3x plus 2. My parentheses are the same, so we're good to go. Factor that out, that gives me 3x plus 2. Wait, 3x plus, we get the same expression. Sometimes that's going to actually happen. But we could actually go a step further with words. So we could write this as 3x plus 2 squared, which actually means this original quadratic here is a perfect square, which now looking at it, you could actually tell that, wait a second, 9 and 4, those are also perfect square. So maybe there's a connection that we'll talk about a little bit further about how we could identify if a quadratic is a perfect square.